Sure. Great. Thank you so much, everyone, for joining in this session. Post-lunch sessions, I know, are quite difficult, and that is why they told me that you have to finish up everything in 15 minutes. So before I start, how many of you here have like more than 2 devices right now with you? Right. And how many chargers do you have? So there are some who have 1 charger, there are some who have 2 chargers. I'm assuming everyone over here would be able to relate to this image here. Maybe a few years ago, you had a laptop, you had a tab, you had a phone, and you had a charger for all 3 of them. And traveling with them or moving around or getting them charged was always really very difficult. That's when the industry realized that, okay, hey, we need to get rid of this and probably move to a common standard. And then all of this was replaced with a USB Type-C cable. So I'm assuming at least 80% of the people in this room have USB Type-C charging for their phones or their laptops or their tabs. Is that correct? Yeah, cool. And that is where MCP comes in. So when I had submitted this talk, I think this was back in February, MCP was relatively new, but then today MCP is Godspeed. I think everyone is coming up with a new MCP server or functionality that's provided. How many of you all know what MCP is? Okay, 20-25%. So for the others, I think you would still find this session a little helpful. And like I said, I was given only 15 minutes to complete this, and this is something that would take at least a few years to probably figure out. So I'm just trying to scratch the surface over here, and we'll understand what MCP is, why we should use it, what are the benefits, and if time permits, I would probably show you something what I would have built. Quick introduction about me. I am Atul Priya Sharma, and I work as a senior developer advocate at InfraCloud, which is an improving company now. As part of my role, I do a lot of things around cloud native, Kubernetes, platform engineering, and Gen AI. Like Ram was mentioning in the morning, if you don't have Gen AI, people don't accept you in the society anymore. So I do dirty my hands around that. I'm a CNCF ambassador, and I organize meetups in Hyderabad, Cloud Native Hyderabad, KCD Hyderabad, so on and so forth. So if you want to know more about what I do at work, there's my LinkedIn, there's my Twitter and Instagram handle where you can check. When I'm not working, some of you might know I'm a big-time foodie and a travel blogger. So whenever I am into a new city, especially like a Bangalore, I would have probably added a Vidyarthi Bhavan or a CTR or a Mahalakshmi tiffin to my itinerary to go and explore and share those stories. So if you want to know what I'm up to outside of work, Atul Maharaj on Instagram, socialmaharaj.com, my blog, where you will see everything outside of work. Moving on, I'll do a little bit of history lesson here. How many of you all are interested in history? I probably expected that. I love history. I'm a big museum geek. And I feel that, when you try to understand how things originated, you try to make better sense of it. So I'll touch upon how the evolution of software actually started. And I'm sure a lot of you would know a lot of these things, so you can quickly go through them. Initially, we had the monolithic era, right? All the applications that you developed were monoliths. So basically, you had a huge single chunk of code that was doing everything for you. And that was for a long time pretty much a standard way of building applications. Now, in this case, what happened was every time you wanted your code to interact with an external application or a data source or a file, you had to write a custom configuration for it. So let's say you had to interact your code with MySQL. You'll write a custom configuration for it. The moment it changes to, let's say, a MongoDB, you'll have to replace and write something again from scratch. And also, it added a lot of overheads when it came to managing. Because now if anything went wrong in a monolith code, you had to spend a lot of time finding out where the issue is. You might have to get your entire application down because you're fixing something because the entire code base is single. To overcome this, we came up with microservices. So we deployed everything in small, tiny microservices. And now these are all scalable. These are all independent. And here, the communication between microservices happened using REST APIs, custom APIs, GraphQL, things like these. Now here we moved to a different level. Now we had a different way of dealing with applications and services, and a lot of things were abstracted. Then came the cloud native era. Now these microservices were converted to containers. And containers, when you talk about containers, you have Kubernetes coming into picture. And now when everything was pods, you had to ensure that your pods and your microservices are communicating with each other. Now, in this case, you started using something like a service mesh, which abstracted at a lot of things. So now deciding the load, deciding where the traffic should go, deciding authentication, everything was done by a service mesh. But then in 2024, when the whole AI era started, we had a deja vu moment. So at one side, you had a new model coming up daily. You talk about Llama, you talk about DeepSeek, you talk about Claude, OpenAI. They have a new model coming every time. Now, for these models, you need to add more context because most of these models are pre-trained, so their knowledge is very limited. So to add more context or add more functionality, you connect it with your own memory, your own files, your own databases, so that it has better context of what you are building. Now, in order to do that, if you are using an OpenAI model, you had to write a code you had to write a code that would connect with the database. Now, if your manager comes and says, okay, hey, now we are using Claude, that particular code will not work for that database. Now, you have to rewrite that code again so that Claude can support database. So every time you have a new model coming in, you had to write a code from scratch to connect to a database, Slack, Kubernetes files, or whatever. So here there were a lot of problems. First one was integration problem. So you have the same tool doing the same functionality, but when you just replace the model, everything changes. Whatever you wrote doesn't work anymore. So you have to start everything from scratch. You could not reuse anything. Any code that you have written, it could not be reused because you have a completely different implementation of how that database or how that API would work with a particular LLM model that you're trying to use. When you're building agents, now your agents, a lot of you know with agents is you basically attach you have an LLM, you have a code, you have tools, and those agents are defined to work and do some particular action. Let's say a Kubernetes agent, right? So it will go to my cluster, do a bunch of things and come back. Now when you are building this, the moment there is any change in this, you want to change a database, you want to change a model, you have to redevelop the entire code again. That was a problem. And eventually you had a data source tax. Now in this case, what happened was when you have your own data that you're bringing to an LLM, the way it interacts is completely different for each model. So if you see all these problems eventually go to one issue, which is every time you change a model, you have to write a different code. And that's the problem what Model Context Protocol tries to solve. So MCP is an open protocol which standardizes the way AI agents interact with external tools, data, and services. So if you see here, there's some random pseudo code for OpenAI and Claude. Basically, there's no difference between these two codes because this is what, if you see here, both this code have a very minor difference here because one of them is working for OpenAI, the other one works for Claude, and this is for connecting to the same database. The role, basically the function here is to get the customer, and these both functions are different. So if you, let's say, add a Gemini model, you will have to write the function again. And this is the problem what MCP solves. So in MCP, if you see here, this is again a pseudocode. You define something called this tool. So the tool over here is get customer, and then you have a send Slack message as a tool. Now what this will do is, irrespective of the model that you're using, it will still be able to call this. So you can put your model as a plug and play over here. So you have Slack integration available, whether it's a Claude, whether it's an OpenAI, whether it's a DeepSeek, everything will work because MCP has standardized the way this entire interaction will happen. It has also defined a set of rules, the set of way the requests and responses should happen. So it's a JSON-based protocol. So it has defined everything. So you don't need to change every time you move from one place to other. So in terms of components, there are two major components. One is the MCP client, which is the application that you're using. So it could be your Claude desktop, it could be your OpenAI, ChatGPT or custom agent that you're building. Next is the MCP server. So this server these are the programs that have certain capabilities. And these capabilities have to be things like resources, tools, or prompts. So to understand how, so tools, resources over here is some context that you give to your agent about a particular setup or a particular environment. So let's say if it is working in a Kubernetes cluster, if you're building a Kubernetes-based MCP, this resources would be, let's say, a cluster info. So it gives it more details about what the cluster is, what the node is. The tools would be the actions that you want it to perform. So in this case, it could be get pods, get namespaces, add pod, delete pod. These are the various actions that your MCP can perform. And last are prompts. So you can define a predefined prompt for every tool. So every time you make a request from the client, the MCP server will intercept it. Based on the tools access it has, it will execute it, pass it onto the LLM, get the details, and give you the response. So that's how basically MCP work. So you'll have first discovery where the client asks the server, what can you do? So basically asking a list of tools. The server will respond with, hey, these are the tools that I have. And then based on that, the client will make a query that, this is the tool I want to use, execute this, and then the results are shared. Now, if I have to explain how this actually works, right? Let's say from a food application point of view. So your MCP client would be like, Macha, what are the tools you have got, Macha? So your MCP server would be like, sir, I got list podu, list namespace, delete podu, rename podu, what do you want? Your MCP client will be like, Macha, find me the best dosa restaurant in Bangalore, book a table for 8 o'clock. Your MCP server will be like, because it has tools for finding the restaurant and it has a tool for booking the reservation. So it will come back, it will use these tools and come back and say, sir, the best dosa is at Vidyarthi Bhavan. I have booked the table for 8 a.m. The MCP client will be like, oh, cool. Now can you find someone whom I can go on a date with for breakfast? Say, sir, I don't have this tool support. You will have to go and download some application to find a partner for your breakfast. So this is essentially how MCP would work in real life. Set of tools are defined. If you have anything outside of those tools, your MCP server cannot respond to it. So if I have to get into some code over here, just to show how things work. Initially, like I said, there has to be a function underlying which actually, does the execution. So this is a Python code where I'm using a sub process, and this is a method which is written to get the pods information. So if you see by default, or simply it's just trying to get pods, and I've defined a namespace. So this is one tool that I have defined. So this MCP server has a capability to get tools, get pods. Similarly, if I go down, it has a create pod tool as well, and where I have defined a manifest. Now again, this is hard-coded. Based on your usage, you can define a different manifest or how you want it to work. Third, it could be a delete pod. So these are the raw functions which will be executed. Now, how does the client know that this is an MCP tool or an MCP server? So you create your function and you annotate everything with a mcp.tool. So this tells the MCP client that these are the tools that are available for you. So if you see get pods, this is the tool that we have created, and internally if you see, it's calling the get pods function that we saw. So this is where I have defined the resources. So it's basically getting the cluster details for me. So in this MCP tool, if you see, you have get cluster, you have delete pod, and you have get pods. So here is the configuration. So how do you tell your client that these are the MCP servers that are available to use? So on the left-hand side, you have a simple JSON format, which you go and apply as a setting in your MCP client that you're using. How many of you use Claude over here? Few people. So in Claude Desktop, you have a support for MCP by default. So all you have to do is open the application, go to configurations, edit the JSON file, and this is the part that you have to add. So this will tell Claude that, okay, these are the external MCP servers that you have to use. This is the name. This is the actual code that will be executed, and if any metadata that you want to give. Last week, Claude released remote configurations or remote MCPs for beta users. So until now, what was happening was you could run your MCP server on your local machine only, or on your wherever the Claude desktop is. But with remote MCP support, what you can do now is your MCP server can run on an external, completely different platform, and you could call that using HTTP protocol within your Claude desktop. So if you can see here, this is Claude, and I have an integration for home labs. Let me just go ahead and activate it. So, thank you. So the setup right now is I have right, so this is connected. Yeah, so if you see here, you can see the tools, right? Get pod, create pod, delete pod. So these are the MCP server tools that are available to Claude, and this is Claude desktop. All I have to do is, hey, what are the pods running in my default namespace. So right now, this MCP server is running in my laptop, which is running at home in Hyderabad. On that, I have this MCP server created. There is a K3s cluster that is running. There is a default namespace. There are some servers running. I'm using ngrok to get the endpoint for the MCP server, and that is configured in Claude. So if you see, it has analyzed my local cluster, which is running at home, and in that it has identified these are the 2 pods that are running. So what I wanted to show over here was that with Claude Web, if you're using a tool like Claude, and if you want to add support for MCP, the remote MCP, it gives you a lot more capabilities because within the same workflow, you are able to connect to a lot of things and control a lot of things, right? So a next step for this would be I'll ask Claude to generate some code for me, and because I have created an MCP to apply a file, it will be able to do that. This is a QR code to the GitHub repo. If you want to see the code that I showed, you can scan this code, go to the repo and find it out. Or you can reach out to me. I'll be roaming outside. I can give you the code as well. Here is a blog post if you want to build your own MCP server. This is an implementation of K8 as server. So if you want to implement if you want to implement your Kubernetes MCP server, this is written in Golang. So you can access this blog post completely step by step. So you can run it on your Claude desktop, not remote, but on desktop. And lastly, I think this is the third or the fourth time you would have seen this slide today. KubeCon India is happening in Hyderabad on August 6th and 7th. Make sure you are there. There is some coupon code which you can try and use to get some discount. Group discounts are available and scholarships are available if you need it. That's all for my time. Sorry for taking those extra minutes. You can reach out to me at these handles or you can catch hold of me outside. Thank you so much.
Thank you, Atul. Any questions? All right. Thank you, Atul, for the insight on MCP. Here's a gift from us.